class, here is page 2 of section 5.1, operations with polynomials. So today we're going to start off with defining polynomials in like terms. A polynomial is a monomial or a sum of monomials. Like terms are terms that have the same variable or variables raised to the same power or powers. To add or subtract polynomials, perform the indicated operations and combine like terms. So if we start off with our first two examples and we're adding the polynomials together, I would recommend writing them vertically and lining them up by like terms. So we would have 5g to the third plus 5 plus 2g to the third plus 7. So how many g's to the third do we have? We have 7 g's to the third, or g to the third, plus 12. Do the same thing on the example L. Line up your like terms. X squared minus 3x minus 3 plus 2x squared plus 7x minus 2. So we would have 1x squared plus 2x squared would be 3x squared. Negative 3x plus 7x would end up being a positive 4x. And negative 3 minus 2 would be minus 5. On the next couple that are subtraction, I would recommend changing these to adding the opposite first. So what I mean is take and make this addition and make the opposite signs. Addition, opposite signs. Now we'll do them just like we did the previous two examples. Negative 4m squared minus 6m. Then I have another minus 6m, and I have another minus 4m squared. So I would have negative 8m squared minus 12m. On the second example of subtraction or adding the opposite, write them vertically, putting like terms together, or one on top of the other. So this time I would have 6x squared minus 4x squared would be 2x squared. Negative 3x minus x is minus 4x. And 2 plus 3 is plus 5. On example O, we're just going to combine our like terms. So if you can see, we've got a 27x squared and a negative 14x squared. Those are like terms, and if we combine those, 27 minus 14 would be 13x squared. You can also see that negative 5y squared and 12y are like terms. Negative 5y squared plus 12y squared would be plus 7y squared. Now we're going to get into multiplying. You use the distributive property when you multiply polynomials. When multiplying binomials, this is a binomial, the FOIL pattern is helpful. So I use the FOIL pattern, and y'all will remember that I've talked about this in previous lessons, but I don't do it the standard way of taking the first times the first, the outer times the outer, the inner times the inner, and the last by the last. I set it up so you're seeing it as a distributive property, although the order is in the FOIL pattern. Okay, so the first two are just using the distributive property. we're going to take 2x, multiply it by 3x squared, and we're going to also take the 2x, I put plus because it's a positive 2x, times a negative 5. So that would give us 6x to the third minus 10x. The distributive property, another way to look at it, is you're just multiplying everything on the outside by what's on the inside. So I would have 7a times 6 plus 7a times negative 2a plus 7a times negative a squared. That would give me 42a minus 14a squared minus 49a to the third. Now I will tell you, I would count this right, but the proper way to write this would be in descending power order. So I'm going to write or negative 49a to the third minus 14a squared plus 42a. So either way is correct. The bottom way is preferred. Now when we get to the binomials, remember that what we did was we took the first one and we stacked it. So we wrote it as 2x and a minus 3. Then beside each of these we write 3 times 3x minus 5 times 3x minus 5. That way everything in the first parentheses is multiplied by everything in the second parentheses. This will give us 6x squared minus 10x. Line up the terms when we go down here, so we would have minus 9x plus 15. So our answer would be 6x squared minus 19x plus 15. And you'll see that we will continue to use this pattern the rest of the way through these examples. I think if you do it one way and stick with that way, it makes it a lot easier. Okay, so I have 2 more. Notice this time we're taking a binomial, 2 terms, by a trinomial, 3 terms. So stack the first one, or the smaller one. So if the smaller one was in the back, I would move it to the front first. In this, neither case is like that. So I would take x times x squared minus 3x plus 4 and negative 1 times x squared minus 3x plus 4. So I would have x to the third minus 3x squared plus 4x, and on the bottom I would have minus x squared, notice where I lined it up, plus 3x minus 4. Then combine like terms, x to the third minus 4x squared plus 7x minus 4. That doesn't look very good. That's a minus 4 right at the end. Last one, stack the first one, x plus y, multiply both by the second one, x squared minus 3xy plus 2y squared. So we would have x cubed minus 3x squared y plus 2xy squared. Now on the bottom, this would be a plus x squared y, so we'd put it under the other x squared y. Then we're going to have minus 3xy squared, so that's going to go right here. And then we're going to have plus 2y cubed. So we would have x to the third minus 2x squared y minus xy squared plus 2y cubed. And it'd be fine to leave your answer like that. All of these have the same degree of power, and so there's really no reason to write it, or it doesn't really make sense to rewrite this in descending power order since the powers are the same. The reason I say that is because x squared y, that's to the third, that's a degree of 3, as are these. So is xy squared. So this is fine to show your answer like this. Okay, that's it for section 5.1. I hope that this helps you to do the practice, and I hope you have a great rest of your day.